So I see why my lecture kind of sucked in class, because I obviously had to have been rushed because I spent an hour and a half without any questions and didn't get done with section 2.3. So this is part 2, should be a short video to finish up section 2.3. I'm not exactly sure where my video cut off, but for the last problem that we were working on, let me just write the answers down for the 3 questions so that just in case my video got trimmed a little bit, so you have the answers to that last question that we were working on. So A union C, the first one of the 3 items I was trying to find, has 4, 5, 6, 8, 10, 12, 14, 15, 16, and 18. That's anything that's in the A circle or in the C circle or both. A union B union C, so let me just do this. So A union C, the things that I put in those is the entire A circle and the entire C circle. So anything in any one of those circles came in my answer for A union B union C, or A union C should I say. A union B union C, we wrote for an answer, I wrote 4, 5, 6, 8, 9, 10, 12, 14, 15, 16, and 18. And pictorially, that's anything in any one of the 3 circles. So anything that's not outside the 3 circles is part of A union B union C. So that region is any number that's in the A circle, the C circle, or the B circle. Any number that's in any of the 3 circles, everything except the 11, 13, 17, and 19 need to be part of A union B union C. And lastly, the B union C prime is anything that's in the B circle or outside the C circle. So B union C prime, which we wrote down in a funky order as 4, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, and 19 is anything inside the B circle or outside the C circle. So any number that's inside the B circle or outside the C circle needs to be part of that. So it's anything but those numbers. So these are the numbers that I'm excluding. And the numbers that I'm excluding were just 10 and 5. So it's everything in the universe except the 5 and the 10. So hopefully my video didn't cut so short that I cheated you on the explanation there. If you feel a little shy in the explanation, come visit me, ask questions in class, and I'll try to fix that for you. So the last things I need to do are 2 more Venn diagram problems. And I started to do this, but I don't think I got any of it on the video. So I'm going to do this problem where U is the set 1 through 9. A is the set 1, 3, 5, 7, and 9. And B is the set 2, 3, 4, and 5. It's easier for me to work when I only have 2 subsets rather than 3 sets. So I'm going to make a picture of this, and I'm just going to draw a rectangle for my universe. I'm going to create 2 circles. One I'm going to call A, the other I'm going to call B. It doesn't matter if you switch the A and the B, but I generally do them this way. When I'm filling up Venn diagrams, I fill in the very center first. What A and B have in common is 3. It's also in the universe. I'm going to put that dead center. A and B also have 5 in common. So I'm going to put that in the overlapping regions of the circles. So I've taken care of the 3 and the 5. I still have more elements to plug in. I'm going to fill in the rest of A and the rest of B. B still needs to have 2 and 4. 2 and 4 are inside the B circle but not in the overlapping section. So I've placed my 2 and my 4. A still needs to have 1, 7, and 9. 1, 7, and 9 need to go in the A circle, but not in the overlapping section. So I'll place those. After I've placed the 2, 3, 4, and 5 from the B circle, the 1, 3, 5, 7, and 9 from the A circle, I still haven't placed 6 and 8. 6 and 8 just go free of these circles in the rectangle somewhere. Might as well list my primes. So let me do a whole nother sheet of paper, copy this down. I'm going to list A prime, B, and B prime down to be able to answer the questions. It's nice to have the sets written down that we're dealing with. Do a smaller version of the picture. So set A, set B, in common they have 3 and 5. The rest of A is 1, 7, and 9. The rest of B is 2 and 4, and out in hyperspace is 6 and 8. A were the odds, 1, 3, 5, 7, and 9. B were the numbers 2 through 5. To do primes, it's the rest of the universe. The universe has the numbers 1 through 9. A has the evens. A prime has to have the odds. Any number that's between 1 and 9 that's not in A is in A prime. That's 2, 4, 6, and 8. B prime is the rest of the universe except 2, 3, 4, and 5. Since the universe has 1, it needs to be in either B or B prime. It's not in B, so it's in B prime. And also 6, 7, 8, and 9. They're numbers between 1 and 9 that aren't in B, so that forms my B prime. So those are the sets I'm dealing with for this problem. Now I'm going to union the sets. To do A union B, it's anything that's in A or B in both. So I write down all of A, which is 1, 3, 5, 7, and 9. And I'm going to add to it anything from B that's in B that I haven't included. So I looked at A, I wrote it down. Now I'm going to look at B. B has 2, it's not in my list, I need to add it to my list. B has 3, it's in my list, I don't need to add it. B has 4, it's not in my list, I need to add it. B has 5, it's in my list, I don't need to add it. So A union B are 1, 2, 3, 4, 5, 7, and 9. It's all of A, and that add anything that B has that I haven't already dealt with. The next thing on my list is A prime union B. I'll do it real similarly. I'm going to write down first my A prime set, which is 2, 4, 6, and 8. Leaving room just in case I have to add. I don't really know what I'm having to add yet, but I'll add it in a second. So there's A prime. Now I'm going to union it with B. B is this set. I look at 2. It's already in the list. I don't need to add it. Next thing in B is 3. It's not in my list. I need to add it. Next thing in B is 4. It's already in my set. I don't need to add it. Last thing in the set is 5. I'm going to add it. A prime union B is all of A prime, 2, 4, 6, and 8, adding the 3 and the 5 that B has that I haven't already included. A prime union B is 2, 3, 4, 5, 6, and 8. Last one, A union B prime. That's the prime of this set. So first I do the union, which I've already done. So A union B is 1, 2, 3, 4, 5, 7, and 9. But I want to do the prime of that. The prime of any set is everything in the universe that's not in this set. Well, what's missing from this set? I'm missing a 6 and I'm missing an 8. So the prime of A union B is everything in the universe that's not in A union B, and that's just the numbers 6 and 8. So these 3 answers are done without really looking at the pictures. I can completely get answers to prime problems, complement problems. Prime and complement are interchangeable. I can answer union problems. I can answer intersection problems with completely ignoring my pictures. If I'm like pictures better, then I can do the answers with pictures. To do A union B pictorially, it's the whole A circle combined with the whole B circle. So to find out what A union B is, it's anything that's in the A circle or in the B circle or in the overlapping area. It's everything but what's outside the circle. A union B is anything but that 6 and 8 because it's the numbers 1, 2, 3, 4, 5, 7, and 9 that are either in the A circle in the B circle are in both the A and the B circle. So A union B, anything but the numbers 6 and 8 that are outside the circles. Pictorially, A prime union B is anything that's outside the A circle or inside the B circle. So A prime union B, I do A prime, which is anything outside the A circle. So all of this has to be considered because all of that is outside the A circle. And then, or inside the B circle, this is inside the B circle. The only part that I'm excluding from A prime union B are these numbers. So it's the whole universe, but this blank area right there. So if I find out what numbers are there, which are 1, 7, and 9, those are the only numbers in the universe that aren't part of A union B. The universe is the numbers from 1 through 9. I'm not going to include 1, 7, or 9. So I'm going to include 2, 3, 4, 5, 6, not including 7, not including 9. So that would be 2, 3, 4, 5, 6, and 8. Again, if you peek at the answers that I got, without looking at the pictures in the regions that were described, 2, 3, 4, 5, 6, and 8 were the same for A prime union B. 1, 2, 3, 4, 5, 7, and 9 were the same for A union B. A union B prime is everything outside of A union B. And because A union B is anything that's in either of the circles, A union B prime is this region. Because A union B is anything inside the circles, so prime is the opposite. The opposite of inside is outside. A union B prime is this region outside the circles, and outside the circles are the numbers 6 and 8. And this is why we said this is the numbers 6 and 8, if I could actually write it, okay. And again, that should match up perfectly with the answers that I got when I was just picking around and doing the answers without really considering the pictures and just considering the sets A prime, B, and B prime. Absolutely doesn't matter to me. If your comfort level is working with the pictures, then work with the pictures. If your comfort level is working with the sets without the pictures, work with those. If sometimes the pictures work, sometimes the sets work, just decide what works from you. There isn't a right or wrong thing to do. I only virtually guarantee that for you, for each individual student, there's probably a way that you like best, and that's the way you need to deal with. Yes, because I've done this for so many years, I'm comfortable with both methods. But in general, you're not going to be comfortable with both methods. You're probably just going to pick one of them and just do it over and over again. So again, this last problem we're going to do for this section wants me to draw a picture. I'm going to make 3 sets because I see A, B, and C. Already filled these in. So I have the Venn diagram done, but I'm going to fill it in again just to be practiced with this. But if you want to, you can fast forward the video and just copy what they have. In the very middle is what they have in common, the 3 sets, which is the 3. So I'll fill it in dead center. It's Thunderbird Chief problems for those of you that went to Thunderbird like I did. Fill in the rest of the things that are overlapping. 2 is in 2 different circles. It's in the A and in the C. That's this region here. That region is in the A circle and the C circle, and it's in the universe. The rest of the numbers go just uniquely in a circle. The 1 goes only in the A circle outside the other circles. The 4 and the 5 go in the B circle outside the other circles. Those are all the numbers for the universe placed. If I want to list the sets for this universe, A had the numbers 1, 2, and 3. The universe goes through 5, so A prime is the rest of the universe, which is 4 and 5. B is 3, 4, and 5. So B prime is the rest of the universe, which is 1 and 2. C was 2 and 3, and C prime is the rest of the universe, which is 1, 4, and 5. Doing those quickly, you can pause the videos. We've done this. I did these already, so hopefully you can get these. Last problem combines unions and intersections. I'm going to work from left to right to get these problems done. So the first problem I'm going to do is A union B and then intersect C. pictorially it's a little bit harder for these combined unions and intersections. For me, it's easier to do without the picture, so I'll do that first, and then I'll try to do them with the pictures. So to do A union B intersection C, the first thing I'm going to work with was A union B. So to work this part first, A union B, I take the A set, which is 1, 2, and 3, because A is 1, 2, and 3. B is 3, 4, and 5. And to do A union B, I take the entire A set, and then I start adding anything that I haven't listed. B, I already have the 3 in there. I'm not going to add it again. I don't have the 4, so I'm going to put the 4 in there. I don't have the 5. I'm going to put the 5 in there. So A union B can be replaced with the set 1, 2, 3, 4, and 5. So I'm working from left to right. I'm replacing A union B with the numbers, the set that contains 1, 2, 3, 4, and 5, because union is anything in one set or both sets. Now I'm going to intersect. So I'm going to take the set 1, 2, 3, 4, and 5 and intersect it with the set C, and set C is 2 and 3. And when you intersect, it's anything in one set, it's anything in both sets. And the numbers in both sets are 2 and 3. So A union B is 1, 2, 3, 4, and 5. After I take the union of A and B, I take that union and I intersect it with C, and I get the answer to this problem. And the answer to A union B intersection C is the numbers 2 and 3. I'll do all the things without the pictures, and then I'll come back and do them with the pictures. So the answer to the first of the last 3 questions is 2, 3. The next thing that I'm faced with is A intersection B complement union C. So first I'm going to do A intersection B complement. I'll do this down here. I'll start with A intersection B and do the complement. A intersection B takes the A set, which is 1, 2, and 3, intersections with the B set, which is 3, 4, and 5. So first I'm doing the intersection. A intersection B is what A and B have in common, because the intersection's in common. A intersection B is just the number 3. But I'm asked to do the complement of A intersection B. So A intersection B complement is the complement of that set. The complement of a set is the rest of the universe. The universe has the numbers 1 through 5. The complement of the set containing 3 is all the numbers between 1 and 5 except 3. So it's 1, 2, 4, and 5. So this first set that I'm asked to do, I did the parentheses first. I figured out that A intersection was B. I complemented it and got 1, 2, 4, and 5. Now I want to union that with C. And when I union these sets, I take the first set 1, 2, 4, and 5. I union it with the set 2 and 3. To do this, I take the entire first set, which is the set 1, 2, 4, and 5, and I add anything that the second set has that I didn't already list. I listed the 2 already. I don't need to list it again. I didn't list the 3. It needs to be in the union. The answer is going to be 1, 2, 3, 4, 5. Again, that's not always the case when you have these combinations of A, B's, and C's with unions and intersection. It certainly doesn't always come out to be the whole set, but it can. So the answer to the second problem, A intersection B prime union C, is again 1, 2, 3, 4, and 5. Again, I've done this without the pictures. I'll do it with the pictures in a second if that might make it easier for you to understand. It's still hard when you're combining unions and intersections. Even pictorially, if you're gifted, it might be harder. For this problem, I like to work from left to right, but I do parentheses first. So I'm going to do this parentheses. I'm going to figure out what C intersection B prime is by first figuring out C intersection B. To do C intersection B, I take the C set, which is 2 and 3, intersect it with the B set, which is 3, 4, and 5. Intersecting is what they have in common. Those sets have in common 3. So C intersection B, if that's all I was doing, would be the number 3. but I'm priming that. To prime a set, it's anything that is in the universe that's not in that set. The prime of 3 is 1, 2, 4, and 5. Yeah, the answer is going to be the same. So what I'm going to do is take the A set and union that with the C intersection B prime set. C intersection B prime is 1, 2, 4, and 5. I'm going to take the A, and I know that the A is 1, 2, and 3. Now I'm going to union these two sets. When I union two sets, I take the entire first set. The entire first set is 1, 2, and 3. And then I add anything that the second set has that I haven't already included. The second set has the 1, I've included it, I don't need it again. The second set has a 2, I have included it, I don't need it again. The second set has a 4 and a 5, which I haven't included, so I needed to add those. All 3 of these answers for this problem is 1, 2, 3, 4, and 5. That's not going to be the case always, but it is here. When we get to the homework problems, guaranteed that's not going to be the case. So let me now explore these problems pictorially. Each one, I should get the answers 1, 2, 3, 4, and 5 if I understand the regions of the graph that I'm asked to explore. So the first one wants me to do A union B intersection C. My first answer can't be right. A union B intersection C should be 2 and 3. And did I actually do something wrong? Oh, so all these answers weren't 1, 2, 3, 4, and 5. The first answer was 2, 3. The next 2 answers 1, 2, 3, 4, and 5. So that's better. It would be bad if all the answers were 1, 2, 3, 4, and 5. So for this answer, I'm striving for 2, 3, not for 1, 2, 3, 4, 5. My memory kind of spaced on me, and I forgot the answer to that. So this answer is supposed to be 2, 3. How I get this pictorially is first I find what A union B asks me to look at. A union B says anything in the A circle or the B circle or both. So the A union B part of this is this whole circle and that whole circle. That's what A union B is. When I intersect with C, I need to find out what this region right here has in common with C. So how this graph and the C graph overlaps. C is this region right here. And where the A union B intersects or overlaps with the C is this region right here. So the region that my answer is going to be is any number that's in the C circle along with the A circle or the C circle along with the B circle. That's the region that I'm looking for. When I look at my graph, it's these 3 regions. The only numbers that are in these 3 regions are 2 and 3. The answer to A union B intersection C are the numbers 2 and 3. For me, it's much easier to do those without the picture and just do those with the set. So my set explanation for me would be easier to follow than my picture explanation. But if you're pictorially gifted, then maybe the pictures just were easy for you. The last 2 that I need to deal with are going to have everything, every number being focused on, maybe for different reasons. They might actually focus on different regions, but just happen to have everything. So the second one is A intersection B prime union C. A intersection B prime, scrub this, that's already a cruddy start. A intersection B prime is everything outside the A and the B circle. So when I work with this, A intersection B prime, that by itself is everything but, so this is the A intersection B region. I want everything but that. So this is A, this is B, this is C. A intersection B prime is everything that's not part of A intersection B. So it's everything outside the intersection. This little region's the intersection, so it's everything but that little region in the middle. So that's the beginnings of this problem pictorially. I have to understand the region A intersection B prime. That's everything but this little football-shaped figure in the middle. And now I'm going to union that with C. So to this picture, I'm going to add every one of these regions that make up C. Because you add. The only region that's ignored in A intersection B prime union C is that region right there. If there was a number in this region right there, the answer wouldn't be the entire universe. There is a region that's being excluded by A intersection B union C, just isn't a number in there. So the numbers that I'm searching for any number that's not in that region, and that's the numbers 1, 2, 3, 4, and 5. So the region, this is 1, 2, 3, 4, and 5, is because the only region that this graph is excluding is a region that doesn't have a number in it. Had I constructed the set so that was a number right there, this answer wouldn't be the whole universe. So again, pictures are hard for me with intersections, primes, and unions. I do parentheses first. A intersection B is the overlapping region, but the prime of it is everything but the overlapping region. And then I union that. I add all C to that. If this was intersection, it would be a different answer, but it's not. In the last one, A union C intersection B prime. First I worry about the C intersection B prime because it's a parentheses. I have my A set, my B set, my C set. C intersection B is this region right here. I want the prime of it, so I want everything but that region of the graph to be considered. So there's my picture of C intersection B prime. Now I want to union that with A. So to this region, I'm going to add the entire A circle. Here, here, here. It's supposed to be like that. I didn't do so well there. C intersection B prime is everything but these two regions. Those two regions, the overlapping football area, that region is the overlapping between C and B. That's not part of the prime. Now I'm going to union this with A, so I'm going to add in all of A. The only region that's not being considered when I union these two is that region right there. Again, had that region had a number in it, my answer wouldn't be the whole universe. But in this case, I want any number that's in either the A circle or outside the C intersection B region, and that is the whole universe. It's 1, 2, 3, 4, and 5. It's everything but any number that would happen to be in this little region right there. Because that region was free of numbers, I don't put anything in that. There's nothing to exclude from the universe. So these last three problems for me, the pictures are tough. You have to be really visually gifted and really understand the difference between unions, intersections, and complements to be able to do these problems via just looking at the pictures. I think for these problems, doing your parentheses first, working from left to right, just using the roster form of the sets is probably easier for me. So you might blend on the test. For some problems, you might use pictures. For some, you might use the roster form. You might find it safe just to use the roster form for every problem. If you understand that, that's fine. It's whatever you understand. The picture strategy, the Venn diagram approach to get the answers, as well as the roster techniques to get the answers, they'll lead you to the same place. There isn't a right and a wrong way to do this. It's just a matter of preference. I would imagine that the roster way is, it might be longer, but it's generally easier. And the picture way is way quicker if you understand the pictures perfectly. If you don't understand the picture, what the pictures are telling you and what the questions, how it relates to the picture, you can get the wrong answer real quick, and it's hard to give partial credit for approaching the problems using pictures. It's easier to give partial credit if you use rosters because I can see your mistakes easier. So this is the end of 2-3. Hopefully I come back in and record maybe another video to fill in any gaps that you might have. I might do the review video so that you can see what you really need to know out of this section. Thanks.